Grade 7, Chapter 10, Lesson 4, Compare Populations. A double box plot consists of two box plots graphed on the same number line. A double dot plot consists of two dot plots that are drawn on the same number line. You can draw inferences about two populations in a double box plot or double dot plot by comparing their centers and variations. The centers and variations to use are shown. So we have to look at the spread of our data. We have to look at its shape. If both sets of our data are symmetric, we're going to use mean for the measure of center and mean absolute deviation, or MAD, for the measure of variation. If neither set is symmetric or only one set is symmetric, either case, we are going to use median for the measure of center and the interquartile range, or IQR, for the measure of variation. Casey surveyed a different group of students in her science and math classes. The double box plot shows the results for both classes. Compare their centers and variations. Write an inference you can draw about the two populations. So she wanted to know, how many times have you posted a blog this month? Okay, so if we look at our data and we look at the shape, they both are skewed. Okay, this one is skewed right, this one is skewed left, which means they're not symmetric. If they're not symmetric, we are going to use the median and IQR. And let's just jot down a note to ourselves here. Not symmetric. So we will use median and IQR. I like to draw myself a little table to help me organize my information. We have math and science class, and we're finding the median and IQR. Math and science. Nothing fancy. To find the median of a box plot, we just look at that center vertical line. So this is math. If we draw it down, it's at 10. So the median for math is 10. The median for science, if we look at the middle vertical line, is 20. Interquartile range is concerned with the inside of the box, the range within the box. To find that, we take our third and first quartile and subtract them. Meaning, for math, if we drag this down, we have 20, and we drag this side down, we have 5. So our IQR is 20 minus 5, or 15. Let's do the same for science. We do the upper quartile, which is 25, and the lower quartile, which is 15. 25 minus 15 is 10. So if we compare them, we can say that math has a smaller measure of center and a larger measure of variation. Than science class. That right there is our comparison piece. Okay, that's only part of our answer. So let me go ahead and box this. That's part of our answer. The other part is to make an inference that you can draw about the two populations. For this, we need to know what this data is portraying. And in this case, it's how many times you've posted a blog this month. So if we take a look, let me erase all these markings here. If we take a look, even visually we can see it, although we have the numbers to back us, we can visually see that science, most of my data is higher than math class. So we can say that more students post blogs in science than in math. So again, I can say, and I'm going to use the word generally. Generally, students post more blogs More blogs in science than math. And that is the second part of our answer. Oops. That should say math. There we go. Letter B. The double box plot shows the cost of MP3 players at two different stores. Compare the centers and variations of the two populations. Write an inference you can draw about the populations. So we need to look at the shape of the distributions. The shapes, neither of them are symmetric. Bargain basement's close, but it's still not symmetric. Okay? Because they're not symmetric, again, if we take a look at our table, neither is symmetric. We are going to use the median and interquartile range. Again, I'm going to jot down a note for myself. Not symmetric. Therefore, median and IQR. This way you know why you're choosing what you're choosing. Okay. So this is just like the one above. Again, I'm going to make myself a little chart. We're doing median and IQR. And we are doing this for electronics world and bargain basement. Okay. Our median, again, is that center vertical line, that center bar. So 70 is for electronics world. And bargain basement is at 60. The IQR is our upper quartile minus our lower quartile. So 75 minus 65 for electronics world, which is 10. And for bargain basement, we have 65 minus 55, which is also 10. Okay, so comparing the populations, we can say electronics world has a higher measure of center than bargain basement, and it has the same measure of variation as bargain basement. That's our comparison. Now we're talking about the cost of MP3 players. So if you were to look at this plot, which one would you say costs more? Looking at it, I can see how electronics world definitely is higher than bargain basement. Most of the data is well above bargain basement. So let's add that information in. So this is our inference. Oops. So we are saying that generally MP3 players are more expensive at electronics world. And that is our answer. So I'm going to go ahead and box this. Okay. The double dot plot shows the daily high temperatures for two cities for 13 days. Compare the centers and variations of the two populations. Write an inference you can draw about the two populations. So it looks like we are comparing daily high temperatures for Springfield and Lake City. Okay. Well, they're both symmetric. Because they're both symmetric, if you look back at that chart, we are using the mean and mean absolute deviation. So again, I'm going to make myself a note. It's symmetric, so we will use mean and mean absolute deviation. Okay. I'm going to actually see if I can move this down. Maybe not. Okay. No big deal. Okay. here's what's really great about finding the mean or average on symmetric data. Because it's symmetric, the mean will be the peak. It'll be the center number, no matter what, as long as it's symmetric. Okay, so let's go ahead and make our little chart. We are finding mean and MAD for Springfield and Lake City. So again, our mean is the peak. It's the middle data value. So our mean is 81 for Springfield. And our mean for Lake City is 84. Here's where it gets a little complicated. To find the mean absolute deviation, we need to first be focused on where the mean is. So let me do one at a time. Let me do Springfield first. Our mean is 81. So there are 3 circles here, so I'm going to put 3 zeros because our mean always gets zeros. If I look at this data value, 80, it is 1 space away from that mean. So I'm going to make these both 1s. Looking at 79, it is 2 spaces away from the mean. And looking at 78, it is 3 spaces away from the mean. And we're going to do the same to the other side. 82 is only 1 away from 81. 83 is 2 away. And 84 is 3. Okay, before I continue, I'm going to do the same process on Lake City. So again, our mean for this one is 84. So I'm going to give this all zeros. 83 is 1 spot away. 83 is one away from 84. 82 is 2 spaces away. And 81 is 3 spaces away. Do the same on the other side. 85 is 1 space away. 86 is 2 spaces away. And 87 is 3 spaces away. What I'm trying to show you here is a little bit of a shortcut way to find the mean absolute deviation, to make it a little as not confusing as I can. So now what we do is we take these numbers and we average them. So let's add them all together and then find then divide by the total number. So 3 plus 2 is 5, plus 2 is 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There are 18, total is 18, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 data points. So now divide 18 divided by 13, and we get, I'm going to round it, 1.38. Let's do the same down here. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 again. Let's count the points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, it's the same thing, so I'm just going to go ahead and write 1.38 again. So the mean absolute deviation for both of these is 1.38. So now let's compare them. Okay. Well, it looks like Lake City has a higher measure of center as Springfield, and the measures of variation are the same. And now let's make an inference. We're talking about daily high temperatures. Looking visually at the data, Lake City definitely has higher temperatures. Okay, so that's what we're going to say. Okay, I'm going to say generally, Lake City has higher temperatures. And there's our answer. Letter D. The double dot plot shows the number of new emails in each of Pedro's and Anika's inboxes for 16 days. Compare the centers and variations of the two populations. Write an inference you can draw about the two populations. Okay. They're not symmetric. So we're going to use median and IQR. Okay. So before I make my table, I need some space because to find the median and IQR on a dot plot, I need to list the numbers. Okay. So here's how we list them. I'm going to start with Pedro. He has 32, 32, 33, 34, 34, and so on. We're going to list them that way. And I'm going to zoom in a little bit so I have more space. So again, this is Pedro. 32, 32, 33, 34, 34. There are 3 35s. There are 4 36s. And there are 4 37s. Let's fix that one. Okay. I'm going to go ahead and list my other one as well. It's Anika. There's 3 30s, 4 31s, 3 32s, 2 33s, 2 35s, 136, 137, and 138. Okay. To find the median and IQR, we need to split the data. We need to find the halfway mark. I always like to start with my ends, and I need to find the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 8 is half of 16. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to draw a vertical line between the 35 and the 36. And in between 35 and 36 is 35.5. Okay? Then I need to find half of this data. Well, I know there are 8 values, so I'm going to draw a vertical line after 4 of them. When the numbers are the same, it's just that number of 34. I'm going to do the same on the right. It's just like if you were to draw your box plots. Again, there are 8 digits, so after 4, we're going to draw a vertical line, and that's 36.5. Let's go ahead and do the same for Anika. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So halfway is the 9th value. So here's my low and my high. 1, 2, 3, 4, 5, 6, 7, 8, 9. The second 32, it goes through that number because there's an odd number of data. I have 8 values. So 1, 2, 3, 4, 1, 2, 3, 4. So I'm going to draw a vertical line in between the 31s. because that's halfway between those. And halfway between these, 1, 2, 3, 4, is between the two 35s. Okay. Now let's actually calculate these. I want the... Okay. This is Pedro, so I'm going to do the... we need the median and the IQR. Oops. Median and IQR. I'll do this table a little sideways here. So this one's going to be Pedro, and this one's going to be Anika. Okay. So the median is going to be that middle number. The median is going to be 35.5 for Pedro and 32 for Anika. Oops. And the IQR, you're going to subtract these numbers. So the IQR is going to be 36.5 minus 34, which is 2.5. And for Anika, 35 minus 31, which is 4. Okay, so now let's compare their centers and variations and then write an inference. So we can see from here that Pedro has a higher measure of center and a lower measure of variance. Okay. So Pedro has a higher measure of center and a lower measure of variation than Anika. And our inference, well, if you look at the table, I'm sorry, not the table, if you look at the graph, the plot, the data, it looks like Pedro gets more emails. So that's going to be our inference. Generally, Pedro gets more emails. Let me zoom out so you can see this. This is our answer. I'll zoom in just a little more so you can read the answer. Go ahead and pause if you need to pause. Letter E. The double box plot shows the daily participants for two zipline companies for 1 month. Compare the centers and variations of the two populations. Which company has the greater number of daily participants? So this one doesn't want an inference. It's asking you a straight up question. Okay, so let's keep that in mind. All right, the data are not symmetric, which means we're using the median and IQR. Okay. I like the median and IQR, especially on box plots. It's painless, quick and easy. Okay, so we want the median and IQR. And we want this for Treetop and Zip Adventures. Okay. The median for Treetop Tours is at 70. And the median for Zip Adventures is at 50. The IQR, again, we take our third quartile minus our first. So 80 minus 50 for Treetop, which is 30. And for Zip, we've got 60 minus 40, which is 20. We still have to compare them, and it looks like Treetop has both higher measures of center and variation. So Treetop Tours, yes. Treetop Tours has a higher measure of center and a higher measure of variation than Zip Adventures. And remember, this one asked us a question. We don't want an inference. Which company has the greater number of daily participants? Well, Treetop definitely has more. Treetop Tours has a greater number of daily participants.